You may have noticed that every question in the textbook for first principles involves an original function that has constants, linear terms, or quadratic terms. But you should be aware of how we can use first principles to differentiate a cubic, and we should also be aware how we can use first principles to differentiate root functions. So to help you differentiate this cubic, this is a very useful trick here, this formula for a plus b all cubed. And I recommend memorizing this: a cubed plus 3a squared b plus 3ab squared plus b cubed. You'll notice that the powers of a go down by 1 each time. 3, 2, that'd be 1, and then a to the power of 0. We don't need to write because a to the power of 0 is just 1. And the powers of b go up each time. So the first term is your b to the power of 0, which we don't need to write. Then we've got b to the power of 1, b to the power of 2, b to the power of 3. And the numbers in front go 1, 3, 3, 1. Okay, so that might be a useful way to help you memorize that expansion. Alright, so let's recap how we differentiate using first principles. So the first step is to work out f of x plus h. So wherever there's an x, we put x plus h in brackets. So that's going to be x plus h all raised to the power of 3. Okay, now we're going to use our little trick here to expand it. So it's going to be x cubed plus 3x squared h plus 3xh squared plus h cubed. So that's f of x plus h. Okay, now we're going to write down our definition of the derivative. That f of x equals the limit, or lim, as h goes to 0, of our difference quotient, which is f of x plus h minus f of x over h. Let's substitute in. So limit as h goes to 0. F of x plus h is here, so let's just rewrite it. X cubed plus 3x squared h plus 3xh squared plus h cubed. Now we've got to minus the whole function. Now the whole function is just one term. Okay, so we're minusing x cubed and then over h. Note the x cubed and the minus x cubed will cancel. So we'll get lim as h goes to 0. And remember, what we do at the next step is we factor out a h from the numerator. So let's factor out a h. What's going to be left for the first term is going to be 3x squared there. This bit we're going to have a 3xh. And because I've taken a factor of h out, the last term is going to be h squared. Over h, we can cancel out those h's. And then we substitute in, now that I've gotten rid of that h on the denominator, I can essentially substitute in the 0 there to work out the limit. And when we do the step of substituting in the 0, that's the step where we can remove the lim. Okay, so I can, for my final line only, remove that lim and just go straight to 3x squared plus 3x times 0 plus 0 squared. And if you simplify that, that's just 3x squared. So f dash of x is 3x squared. Okay, so be aware how to use first principles for a function that is a cubic. Okay, and you should also just be aware of the special case of a function that's a root. So that's what we're going to do now. But before I move on, I just want to remind you of a few key following things. This formula to work out the derivative, the limit as h goes to 0 of the difference quotient, you've got to memorize that formula. That's not on your reference sheet. Okay, it's not on the reference sheet. And remember, at each line we write this lim h goes to 0, lim h goes to 0, all the way up until we substitute in h is 0, and then we evaluate. Alright, let's do this one. So use first principles to differentiate square root of x. So first step for first principles is we write down what f of x plus h is. Okay, so remember that we replace all x's in the function by x plus h in brackets. So that's what we've got there. That's my f of x plus h. And we can't really go any further with expanding in this particular case. So let's write down our definition of f dash of x, my derivative. or gradient function, it equals to the limit as h goes to 0 of the difference quotient, f of x plus h minus f of x, all divided by h. Substituting in, it will be limit as h goes to 0. F of x plus h is root x plus h minus f of x, and f of x is just going to be, put in brackets, root x over h. Because there's one term for f of x, you don't really need the brackets. You only really need that bracket when there's more than one term. For example, if there was like a plus 5 there or something, you would need brackets for that bit. Alright, so we get to this stage, and note we can't sub in h as 0 at this stage because we'd be making the denominator 0. So we obviously need to manipulate this further. And at this stage, this is where we do the trick of rationalizing the numerator. Now, you might remember for surds, when we've got, for example, a surd like, if the root x plus h minus root x was in the denominator, and I wanted to rationalize that denominator, we multiply by what we call the conjugate, by timesing by the conjugate. And remember, the conjugate is the exact same thing, but with a plus in the middle. And by doing that, we could rationalize the denominator because the denominator becomes a difference of 2 squares. Here we're going to do the exact same thing, but we're doing it for the numerator. Okay, so we're going to multiply by the conjugate, and then we're going to use the fact that a minus b times a plus b is a difference of 2 squares, which is the first squared minus the second squared. Okay, and you might wonder how this is going to get rid of that h down the bottom. Well, we'll just wait and see what happens. Okay, so let's go. So lim h goes to 0. Remember, we always need that lim h goes to 0 bit at the front. This I'm going to put in brackets, and I'm going to times top and bottom by root x plus h, and then plus root x. And then what I'm going to do is I'm going to expand that top, which is now a difference of 2 squares. So if you square the first, if you square the square root will go away. Okay, so it becomes, if you square root and square like that, and then minus root x all squared. First squared minus second squared, using the difference of 2 squares formula. Okay, over, and that'll be h times by root x plus h plus root x. Okay, let's simplify. So I'm going to remove the square root and the square, so that'll be x plus h minus x. Okay, over, and then we've got h root x plus h plus root x. And hopefully you can see that something interesting happens on the numerator here. We've got an x and a minus x, and they cancel. Okay, so let's see what we've got left. Limit as h goes to 0 of h over h bracket root x plus h plus root x. H's will now cancel. So we'll get limit as h goes to 0 of 1 over root x plus h plus root x. And notice I've got rid of that h down the bottom. So now we can substitute in h as 0. Let's see what we get. We get 1 over root x plus 0 plus root x. Now x plus 0 is just x. So that's just a root x plus another root x. So when you simplify that, that's going to be 1 over 2 root x's. Okay, so if you want to know what the derivative of root x is, it's 1 over 2 root x. So let me just write that a bit clearer. Therefore, f dash x equals 1 over 2 root x. Okay. So key message from this video, if you want to use first principles on a cubic, use this particular formula here to help you expand the x plus h or cube bit. And if you have a square root and you want to differentiate by first principles, you rationalize the numerator by timesing the numerator by its conjugate, and that makes the numerator a difference of 2 squares, and things simplify that way. Alright, see you in the next video.